Namaste everyone. Welcome back to optics classes. We have seen many things in ray optics, the mirrors, reflection, mirror formula, problems related to mirror formula, and now refraction, Snell's law, then refraction through a prism. That's what we are discussing now, and some few problems in refraction, right, in a prism. Now we will move on to a few more problems, 2 or 3 problems, so that it will help you to move forward. Okay, so now you have the display, you can write the problem. A ray of light incident normally on one face of a right angled prism. What do you mean by right angled prism? The angle of the prism, that is angle between the two refracting faces, is 90 degrees. And its refractive index is 1.5. It emerges grazing the hypotenuse face. That means it just undergoes total internal reflection. It undergoes very just total internal reflection. Calculate the angle of the prism. Okay, 41 degree 49 minutes, that is the answer. 49 minutes can be divided by 60, it becomes 0.8 almost. 41.8 degrees, that should be the answer. 41.8, almost. 41 degree it is. Okay, so read the problem again. You write it, a ray of light incident normally on one face of a right angled prism of refractive index 1.5 emerges grazing the hypotenuse face. Calculate the angle of the prism, right? Okay, you take enough time to write it, then we will move on to the problem. So at the same time you have to draw a diagram. A ray of light is incident on one face of a right angled prism. Okay, refractive index is 1.5. And it should be incident normally on one face. Okay, come back to the problem. I will draw a right angled prism, cross section of the principal cross section of the prism like this, right angled prism, and it is not told it is isosceles, nothing is told like that. It's a right angled prism, so I have to use the two refracting faces. A ray of light is incident normally on one face of a right angled prism of refractive 1.5. Yeah, it should graze the hypotenuse face. That means angle of the prism need not be 90 degree only. It is called right angle prism, right? It is called right angle prism. That doesn't mean that angle of the prism is 90 degree. You have to incident the ray in such a way that it grazes the hypotenuse face. If it has to graze the hypotenuse face, we can't use these two surfaces. You have to use the hypotenuse as one of the refracting face and one of the face here. So I will choose the ray of light like this. A ray of light incident normally. So how can you call, or how will you get the first angle of incidence? It is 0 because the ray of light is along the normal and it passes undeviated like this. So angle of first refraction is also 0, and of course this is taken as I. What is the angle of emergence? According to the problem, it grazes the hypotenuse face. So I will change the color for the ray. Yes, it is like this. It grazes the hypotenuse face like this. It moves parallel to the hypotenuse face. Of course, you can't use these two refracting surfaces and call the angle of the prism as 90. It is given right angled prism, but angle of the prism is not 90 because the angle of the prism is that angle which is made by the two refracting faces. Two refracting faces are these two. This is the angle of the prism, and it is not even 45 because it is not isosceles, and it is the question itself, calculate the angle of the prism. Okay, we will move on. Refractive index of this is given, nothing is told about the outside medium, so we will take it as air. Refractive index is 1, inside medium is 1.5. So we are given with so many values, but not directly, it is hidden in the problem. Incident normally, I0, R10, what is R2? So shall I write R10 somewhere else? So I will write it somewhere else, so that I can write some other thing also here. So this is incident normally. So R1 is 0. R1 equal to 0 I will write. Now I will imagine a normal here, normal to this surface. This is the second angle of incidence, right? Angle between incident ray and normal to the surface. This is R2 and I call it as IC. What is IC? Critical angle. Sir, why it is critical angle? The ray grazes the surface after refraction, 90 degrees. Angle between the final emergent ray and the normal. That's all you have to consider in this problem. Once you get all the values, so I0, R1 0, R2 critical angle and 90 degree, they are asking you what is the angle of the prism. This angle of the prism, this should be the angle of the prism, A, and that angle of the prism is nothing but R1 plus R2. So A is equal to R1 plus R2. And if you put the values here, R1 is 0, first angle of refraction here, R2 is IC, critical angle, then A is equal to IC. So that implies A is equal to critical angle. Now, how to get the critical angle? You know the relationship between critical angle and refractive index. Or you just apply general law of refraction. You go from here to here. Ray of light is incident at an angle such that it undergoes refraction at 90 degrees, grazes the surface. If it grazes the surface, I can write 1.5 sin IC, 1 sin 90, because this is air and refractive index is 1. So apply the general law. 1.5 sin IC, Snell's law, is equal to 1 sin 90. So once you get IC itself is A, right? So A itself is IC. So what is sin IC? Sin IC is equal to, sin 90 is 1 by 1.5, and this is 0.6667, I think. 0.6667. It is 15 6 are 90, then again 10 remaining, 6 are like this. Okay, then what is IC? IC is equal to sine inverse of 0.6667. Now you have to go in search of 0.6667. What is the answer? So we have seen the answer. It should be 41 degree, something like that. Let us see whether our answer is correct or not. You have to get into natural science table, and you have to search for natural science table. 0.6667 you have to search. 0.6667 is in 0.66. It is in 41 degree, and yes, 65 we have 47.8 degrees it is, because you have 0.6665, that number. So 41 degree, 0.8 degree column, 41.8 degrees. This is what you get. So that is the angle of the prism. So angle of the prism is itself critical angle. It is 41.8 degrees. That is the answer. Okay. So a very easy problem. Only the thing is you must know how it grazes the surface. Just undergoing total internal reflection here. Let us move on to the next problem. Next problem. Okay. Yes. An equilateral prism produces yes, read the problem. An equilateral prism produces a minimum deviation of 40 degree in air. What is the refractive index of the prism? This is a minimum deviation problem. We have not solved such problems. What is the refractive index of prism? If the prism is placed inside water of refractive index 1.33, what will be the new minimum deviation angle? Okay. An equilateral prism is placed and it produces a deviation of 40 degree in air. What is the refractive index of the prism? Okay. So we have to use minimum deviation position formula, because purposefully in the problem it is mentioned clearly that it is minimum deviation. So you are not allowed to use A is equal to R1 plus R2. You are not allowed to use D is equal to I1 plus I2 minus I1 plus I plus E minus A. That is not possible. Only minimum deviation formulas. Okay? We will come back to the problem. It is given equilateral prism. So whatever the angle you take, it should be 60 degree. If it is equilateral, whichever the surface through which the light passes is considered, angle is 60 degree, because all the three angles are equal, and it produces a minimum deviation of 40 degree in air. So minimum deviation of 40 degree in air, that is the next data. What is the refractive index of the material of the prism? So what is the refractive index of the prism? Yeah. So later part we will see it afterwards, that if the prism is placed inside water of refractive index 1.33, what will be the new minimum deviation angle? That is the next one. Now, so you have a prism of angle 60 degrees and a ray of light is incident and it should pass through the minimum deviation position like this. That means this angle should be the least one, and the refractive index is n, here it is 1. So refractive index of the material of the prism is sine a plus dm by 2 by sine a by 2. This is the formula. Okay. Direct problem, n is equal to sine 60 plus 40 by 2 by sine 60 by 2, sine a by 2. Sine a plus dm by 2 by sine a by 2. That is equal to 100 by 2, sine 50 and by sine 30. Of course, denominator you know, 0.5. It is half. What is sine 50? Sine 50 has to be taken from the logbook. Sine 50 is natural science table. It is sine 50 is 0.7660. It is the first column itself, 0.7660. 0.7660. So refractive index is n is equal to, so divide them, answer will be 0.7660 divided by 0.5. Answer, oh, it is double this answer, that's all. You could have taken this as half and multiply this by 2, that's all. 2 0 0, 12, 12, 2 6 are 12, 13, 1 9 and hand 14, 1.5. 1.532 is the answer. That is the first part. Okay? First part of the problem. Now, going back to the problem again. They are asking you, if the prism is placed inside a medium, we will go back to the problem again. If the prism is placed inside water of refractive index 1.33, what will be the new minimum deviation angle? Definitely the minimum deviation depends on both the refractive indices, prism as well as outside medium. Now, when you keep the whole prism inside water, what are all the factors which don't change? We can keep it as it is. One is angle of the prism. Angle of the prism 60 will never change because it will be the same. So angle of the prism itself is 60. Now let us keep it inside water. So 1.33 is given. So coming back to the board now. Now this is 1.33, not 1, and this is the n, and we have got this 1.532. Refractive index of the prism won't change. Only relative refractive index will change. That means what is the refractive index of the prism with respect to water? That will change. But individually with respect to air, that won't change. 1.532, 1.33, and now if a ray of light is incident and it undergoes minimum deviation, angle of the prism will not change. It is 60 degree only. And minimum deviation you can't use it as 40. It's the new value you have to use. And refractive index of the material will never change. This is with respect to air, and this is also with respect to air. Now relative we know. Now you have the formula n21 is equal to sine a plus dm by 2 by sine a by 2. Now we have a little bit of work in the formula. Okay, shall I write the formula? Let the board be available completely so that I can complete it within this range. So n21 is equal to sine a plus dm by 2 by sine a by 2. Okay, so this by 2, right. Now, shall I expand it as n21 is equal to n2 by n1. You know this one, sin I by sin r. So here we have, I will write it here. Here we have 1.532, which is the previous answer, and this is 1.33, and angle of the prism is 60. What is dm? That is the question. Minimum value of deviation. Okay, we will substitute the formula. I'll write this first. Okay, n2 refractive index of the second medium, that is 1.532, divided by n1 the surrounding medium. Last time it was air, now it is water, is equal to sine a is given, dm is not given. So 60 plus dm by 2 by sine 60 by 2. A is same. Angle of the prism doesn't change as the light, as the prism is kept in water. Only the surrounding medium will change. That is 1.33. Now, This is 0.5, right? 1.532 divided by 1.33, that I will calculate and I will do it. This is 0.5. I will cut short the method here. 0.5, 1.532 divided by 1.33 is equal to 1.15, this answer, into 0.5. That means into divided by 2 into 0.5. So the answer is 0.5759. 0.5759. Let me check it again. 1.532 divided by 1.33 into 0.5. Yes, 0.5759. This one is equal to sine of 60 plus dm by 2. Okay? You take your logbook and calculator. Do along with this video, otherwise it's of no use. If you just look into the calculation, what do I do, then I will get the experience, not yourself. You have to do it yourself. Okay? So now, sir, how to proceed forward? Unless you bring this sign here, this doesn't become free. If you want to make this 60 plus dm by 2 free, bring this here. Sine inverse of 0.5759 is equal to 60 plus dm by 2. That's what you can do. What is sine inverse of 0.5759? Again, natural science table. 0.5759 you have to search for just more than 30 degrees, because sine 30 is 0.5. 0.5759. Number is seen in 0.5750 you have, 54 you have, 64, 50 you have. 0.5750, that is enough for me. It is in 35 degrees, 0.7 degrees. 35 full degree, column is 0.7 degrees. 0.5750 I have 0.5750. I'll stop it there. It is 35 degrees, 0.1 degree, not 0.7. It is 0.1 degree. So 35.1 degree. I have this value, 0.5750. 35.1 degree is equal to 60 plus dm by 2. Okay? Then multiply this. 70.2 degree. Double this one. 60 plus dm by 2. 60 plus dm. 2 I have brought it here. So what is dm is equal to 70.2 degree minus 60 degree is equal to dm. That implies dm is equal to, so it has got extra 10.2 degrees, 10.2 degrees. You have the same answer almost. It is 10 degree 20 minutes, it is written 10.3 degrees. If you divide 20 minutes by 60, you will get 0.3, but this is the nearest one. This is enough for us. 10.2 degrees, that is the answer. So once you are asked to find out refractive index of the prism, and another time you are asked to find out what is the minimum deviation if the medium is changed. So we were able to get the answer, right? Correct. That is the second problem. Okay. We'll move on to the next problem. Okay. Yes. At what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees so that it just suffers total internal reflection at the other face? Refractive index of the material of the prism is 1.524. It is just asking as if we had seen one problem earlier. What is the angle of incidence on the first face so that the ray retraces the path after reflecting from the silvered other face? In the same way, here it must undergo total internal reflection, not reflection as in a mirror. It should undergo total internal reflection. That means the ray must be incident in such a way that at the second phase, angle of incidence must be critical angle. But for the first phase, it is not incident normally as we did in the previous problem. What angle should be the incident angle in the first phase so that it grazes the opposite face, right? It just undergoes total internal reflection. That means it should just start. Okay, shall we move on? Just coming to the board. At what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees so that it just suffers total internal reflection? It is 60 degrees, this one. At what angle you should incident a ray of light on the first face of the prism so that it undergoes just total internal reflection here? So it moves like this, and like this. It undergoes total internal reflection, just total internal reflection. So if I draw a normal, we have the experience of solving such a type of problem, very close to a problem which is very close to this. This is IC and critical angle. This critical angle is nothing but it is R2, am I right? Whereas R1 is not 0. Last time it was normal incidence, but now it is not normal incidence. There is I, there is R1, and there is IC, R2. Refractive index of the material of the prism is given 1.532. Now, the thing is you have to find out I. So I cannot be found out directly. You have to go step by step. What are the things you can connect? Sir, can I connect angle of the prism R1 and IC? Yes, you can connect. But both are unknowns. There is no R1, there is no R2 given. So if any one of them is got, then definitely you can get the other, because A is equal to R1 plus R2. Now how to get either R1 or R2? R2 can be obtained by this one. Refractive index N equal to 1 by sin IC. Critical angle and refractive indices are always related. So N equal to 1 by sin IC, or sin IC equal to 1 by N. So you will get IC. Once you get IC, A equal to R1 plus R2. You will get R1. Once you get R1, apply the Snell's law. N1 sin R1, N2 sin I, finish. And this is R, you have to take it this as R. Nothing is told about the refractive index. So that is the procedure. Got it now? The procedure is like this. You want A is equal to R1 plus R2, but both are unknowns. But you can get critical angle or R2 using this N equal to sin IC, N equal to 1 by sin IC. And that gives IC. Once you get IC, using this sum formula R1 plus R2 equal to A, you will get R1. Once you get R1, you can go here using Snell's law. So we will go step by step. One is here. You apply general law, Snell's law itself everywhere. If you have forgotten the critical angle formula, 1.532 sin R2, that means sin IC, equal to 1 here, R is the medium here, so refractive index is 1 sin 90. So I will apply the general law here. 1.532 sin IC, 1.532 sin IC is equal to R1 sin 90, or N equal to 1 by sin IC. You will get that N equal to 1 by sin IC. This will be 1. So what is sin IC? Sin IC is equal to 1 by 1.532. That is equal to, let me calculate what is 1 by 1.532. You can do it yourself. 1 divided by 1.532, that is equal to 0.6527. This is 0.6527. Last time it was 1.5, we got it as 0.666. 15 6 are 90. That's what we did. Now it is 0.6527, right? So let me check it again. 1 by 1.532. So it is 0.6527. Okay. What is IC? IC is equal to sine inverse of 0.6527. Now you have to search this number. So what is IC? IC is from natural science you have to get sine inverse of 0.6527. Go to the natural science table and search for the number 0.6527. If you don't get that, go to the nearest number less than that, 0.6527. Yeah, you have 0.64, 0.65, 0.6534, you have 0.6523. That is enough. So I have 0.6523 in the which row? 0.6523 is found in 40 degree row and then 0.7 degree column. 40.7 degree I can write. So this is 40.7 degree. 40.7 degree. In 40 degree row and 0.7 degree column, you have the number 0.4523. sorry, 0.6523, and but needed number is 0.6527. This is enough. So once we have got IC, you know that sum of these angles is the angle of the prism. Now you will get R1. So we have A is equal to R1 plus R2. We will proceed. That implies 60 is equal to R1 is R1, first angle of refraction. Second angle of refraction is nothing but critical angle because the ray is undergoing grazing refraction. R1 plus R2. R2 is that is IC. So this is R2 itself. IC is 40.7. So what is R1? That implies R1 is equal to 60 minus 40.7. So 60 minus 40 is 20, but 0.7 less because you have to subtract 0.7 also. It is 19.3. Am I right? 19.3 degrees. So if you add this, you will get 60 degrees. 40.7 plus 19.3 gives 60 degrees. So 19.3. That is R1. So once you get R1, so we have got this one, 19.3 degrees. If you get this, again Snell's law, 1.532, this sine, 1 sin I. So that is what is the question. At what angle the ray of light must be incident so that it just grazes the hypotenuse face. So 1.532, I am applying Snell's law here, 1.532 sin R1, sin 19.3 degrees is equal to 1 here sin I, 1 sin I. Now sin 19.3 degree, oh no, we have not found it out, we have to calculate it. 1.532 into, what is sin 19.3 degrees? Again I have to go for natural sines, sin 19.3 degrees. Same page with the natural sines. 19.3 degrees contains which number? 19 degree and 0.3 degrees in the fourth column. It is 0.3305. Yes. 0.3305 is the number in 19.3 degrees. 0.3305. Yes. 0.3305. That is equal to sin I. So what is sin I equal to? Is equal to, so I will multiply that, 1.532. So at any cost it shouldn't be greater than 1 because sin value greater than 1 doesn't exist. So what is the answer? 1.532 into 0.3305. That comes to 0.5063. 0.5063. This is almost half. Angle of incidence is almost 30 degrees. We will see what is I is equal to sine inverse of 0.5063. I is equal to, so you have to again search for 0.5063. You have to see the this natural sines once again. So 0.5063 should be very close to 30 degree. So where is 30? Yeah, 0.5063. 5060 you have 0.5060, that is in 30 degrees. 5060, we must get 5063, 30 degrees, 0.4 degrees, 30.4 degrees. So there is a small difference in the answer that you have got, but that may be because of approximation, but this is okay. Angle of incidence should be 30.4 degrees, and sometimes when we take the last number approximation that keeps on changing, that will bring about half degree or so difference in the answers. So that is the angle of incidence at which the ray grazes the surface. So that is about that problem. Okay, then we will move on to the next problem. Yes, that is this one. An equilateral prism, glass prism made up of material of refractive index 1.66 is immersed under water of refractive index 1.33. Calculate the angle of minimum deviation. Find also the angle of incidence of ray in this position. Okay, they are asking you an equilateral prism, asking you to find out the minimum deviation for a equilateral prism. and it is immersed in water. In that condition, what is the angle of minimum deviation, and also what is the angle of incidence for a ray of light. Okay. Okay. Refractive index is given, surrounding medium is also given, and you are asked to find out, calculate the angle of minimum deviation. Right. Sin A plus dm by 2 divided by sin A by 2. We will list the data. Okay. We will come back to the problem. An equilateral prism, angle of the prism is given 60 degrees. Equilateral, made up of the material of refractive index 1.66, a type of glass, and is immersed in water 1.33 refractive index. Calculate the angle of minimum deviation, dm, is how much, and what is the angle of incidence of this position, I is how much, at this position, to get the minimum deviation angle. Okay, now if you have the formula, n21 is equal to n2 by n1, right, is equal to sin, n2 means it is the refractive index of the prism, n1 is the refractive index of the surrounding medium, sin I by sin R, but you know I is equal to A plus dm by 2, sin A plus dm by 2 by sin A by 2. That is the formula. n21 is equal to n2 by n1, sin I by sin R, sin A plus dm by 2, sin A by 2. So you have this one. You see the list the values which are known. n2 is known, n1 is known, ray is traveling from here to here, right? n2, n1, and here A is known, only dm is missing. So shall we proceed? We will substitute 1.66, okay, n2 1.66 divided by 1.33, n2 is 1.66, n1 is 1.33, because ray is moving from here to here, 1, 2, and always suppose the other medium is air, this will be 1, so then n equals sin A plus d by 2 by sin A by 2. Now there is n1 also, it is water, is equal to, so I will take this formula and this one, sin A plus dm by 2, 60 plus dm by 2 by sin 60 by 2. This is very similar to one of the solution we did just now. So here, of course, this is sin 30, half, I can bring it here. It is a very similar problem, right? We had a second part in one of the previous problem, same type. So what is 1.66 by 1.33? 1.66 divided by 1.33 is equal to 1.248, this one, multiplied by 0.5, because this is half, right? This is 0.5. I will bring it here, into 0.5, into 0.5, yes. It is 0.6240, 0.6240, right? Suppose in case, anywhere, if you get a problem where when you multiply it here and get all the things, sin, and this should be equal to sin 60 plus dm by 2. Sir, suppose we get this answer more than 1, what we will do? Because sin inverse of more than 1 doesn't exist. So, in such a case, that is not possible. You can't have a ray of light for producing minimum deviation position in this prism. That is not possible. So, you shouldn't get any number greater than 1 here, because sin inverse of greater than 1 doesn't exist. So, sin inverse of 0.6240 is equal to 60 plus dm divided by 2. So what is the sin inverse of 0.6240? Go to the sine table again. So you can get this sine table from the Google also. You can download, you can search. There are many pictures of sine and sine, cos and tan tables. Don't keep quiet that I don't have any sine table or so. Nobody will come to you and give you the sine tables. You have to go in search of all those things. Okay, 0.6240. You can get it anywhere, because you have to study this. It is not only the part that how to do this, and understanding this is not at all enough. You must be able to do it very fast in the exam. You must be very confident in looking all these angles and so. 0.6240. 0.6240. You have to search that number. 61, 62, 63, 6239 we have. 0.6239, that is very very close, 6239 I have. That is in 0.6239 is in 39 degree, 38 degree, 38 degrees and 0.4 degree column, 38.4 degrees. So it is 38.4 degrees. 38.4 degrees is equal to 60 plus dm by 2. Okay. Multiply this, 76 and 76.8 degrees is equal to 60 plus dm. What is angle of minimum deviation? Angle of minimum deviation is equal to 76.8 minus 60, it is 16.8 degrees. This is the angle of minimum deviation. Okay. Now there is one more question. There is a small difference between what the answer is written there and what answer we are getting, because that approximation makes little bit of change, but you need not worry. There is one more question. Find also the angle of incidence for the ray of this ray of light in this condition. We have to find out I. What is I equal to? I is nothing but A plus dm by 2, correct? Because you see the formula here, sin I by sin r, right? N21 is sin I by sin r. In the place of I, you just remember the derivation. Derivation says it is A plus dm by 2. So if I want to know what is I is nothing but A plus dm by 2. A is 60 plus dm is how much? It is 16.8 by 2. So that comes to 76.8 by 2. That is that is okay. That is equal to 3 times 38.4 degrees. We have got it already. So that is the angle of incidence, right? 38.4 degrees. That is the angle of incidence. A plus dm by 2. So very easy question. And remember, you have to have the list of all the formulas. What are all the things you have get, and you have to see that formulas again and again. Use it when you solve the problem. Then you will remember it always. So we will move on to a new problem, which is not included for prism, but still it is related to refraction. So we will see the problem. One more problem, then we will stop. When a ray of light in air enters a liquid, it is found that the angle between the incident and refracted rays is 150. See, there is a peculiar angle given. It is neither incident angle, it is not refracted angle. It is the angle between incident and refracted rays. It is 150 degree. And the angle between reflected and the refracted rays is 60 degree. Calculate the refractive index of the liquid. The only challenge here is to indicate all those rays, and from those angles given, 150 and 60, search them what angles they are. From them, by using them, you must be able to get actual what is the angle of incidence, what is the angle of refraction. Once you get that, then general law, Snell's law, sin I by sin r is equal to n2 by n1. That is enough. So we will try to recap, or we will try to indicate it in a diagram. Picturize it. Angle between incident and refracted ray is 150. Angle between reflected and refracted ray is 60. So I will write it here. Angle between incident and refracted ray is 150, and angle between reflected and refracted ray is 60. Reflected and refracted ray is 60. Reflected and refracted ray is 60. That is what is given. So we must be able to put it in a diagram. Okay. Now suppose if you take a ray of light like this, and you know the story is such that the light is entering the liquid, and the other medium, no data is given, it should be air. Okay, this is liquid. Let me take the refractive index of this one as n, and this one air. Refractive index is taken as 1, because light travels with the highest speed, so it has the least refractive index. Now take a ray of light. A part of the light gets reflected. Whenever light falls on water or any liquid, part of the light gets reflected. Otherwise, we may not be able to see the surface of water at all. And most part of the light passes through. And this is the original direction. Let me draw a normal here. Normal to the surface at the point of incidence, right? So it is like this. Now let me try to put the rays of light which are given, angles which are given. Angle between incident ray and refracted ray. Incident ray and refracted ray. That is 150. That is not the angle of incidence. Incident ray and refracted ray. A part of the light gets reflected, part of the light gets refracted. Now, shall I mention this as 150? That is wrong, because the ray which is moving from air to any medium moves towards the normal. So if it is towards the normal, this is the original direction, this itself is 180, and this angle together with this one should be more than 180. It should be 190, 200, something like that. So this cannot be 150, this should be 150, right? This should be 150 from the other side. So that we have to conclude that this should be 150, because we know that the ray traveling, instead of traveling straight, bends towards the normal. So this is more than 180. So one thing is over. Incident ray and refracted ray. Angle between reflected and refracted ray. Reflected and refracted. So I will write this one. Reflected ray, and this is refracted ray, and this is incident ray. Okay. Reflected and refracted rays. Angle between them is 60. So this angle is 60, right? This is 60. Now their question is, what is the calculate the refractive index of the liquid here. What is this one? That is the question mark. Now once you picturize all these angles, then the things become very easy. So it becomes very easy. What is the angle of incidence and what is the angle of refraction? That's all you have to calculate. Now the total angle should be 360. Already we have completed 210 degrees. Out of 210, 360, you subtract this. 360 minus 150 plus 60. Then you will have out of 110, if you out of 360, if you remove 210, then it will be 50 plus 100. 150 degree will be remaining. So this should be 150. Am I right? This angle should be 150. And you know that angle of incidence and angle of reflection are same. So you have to divide 150 into two equal parts, 75 degrees and 75 degrees. That is the angle of incidence and angle of reflection. So you got it, 360. Out of that, 210 is already covered. This should be 150. Divide angle of incidence and reflection equally. So it should be 75 and 75. Now, what is this angle of refraction here? Is there any way of finding it out? Yes, you can do it, because this is a straight line, pink line here. And in the straight line, it should be 180. Already 75 and 60, 135. So 180, so this angle can be obtained like this. 180 minus, this is a straight line, and among out of this straight line, 75 and 60 is already covered. 75 plus 60, remove it from 180. So that is equal to 180. This is 135, 140, 45 degrees remaining. That is 45. So this angle of refraction is, okay, I'll write it here, 45 degrees. So we have got angle of incidence, we have got angle of refraction, we have know the refractive index of this medium, only this medium is needed, that is missing. Snell's law, n1 sin I is equal to n2 sin r, that is enough. So I will write it here, right? n1 sin I is equal to n2 sin r. n1 is 1, sin 75 is equal to n2 is n, that liquid, refractive index of the liquid. Sin r is sin 45. So you have to go on calculating this. Only sin 75 is enough for you. Sin 45, you know it. So what is n? Sin 75 divided by sin 45 gives you the refractive index of the medium, and n is equal to, this is 0.707, because sin 45 is 1 by root 2. You calculate what is 1 by root 2. It is 0.707. Better you remember that answer. Then 75, sin 75, natural sines 75. 75 degrees, 00 minutes or degrees, 0.9639. Yes, 9659. 0.9659 is the Answer for 75 degrees, sin 75. 96, it is 59. 0.9659. That is sin 75. Now what is Yan? Just calculator and get the answer. It should be 1 point something, 0.9659 divided by 0.707, 1 by root 2. That is equal to 1.366. 1.366. That is the refractive index of the material of the prism. Let me check it once again. 0.9659 divided by 0.707. That gives you 1.366. So refractive index of the material of the prism is 1.366. So this is one type of problem. This is related to refraction, and sometimes you may get a problem like this. So I can remember one problem. When a ray of light is incident on certain medium, it is found that reflected and refracted rays are perpendicular to each other. You will get this concept later in one of the property called diffraction or interference or polarization you will get. And now when a ray of light is incident on certain media, the reflected and the refracted rays are perpendicular to each other. This is reflected and this is refracted. Okay, they are perpendicular to each other if it is told. So how to carry on with this problem? If you take this as I, and this is angle of refraction and reflection, and this is angle of refraction, and this is also I, you will get this R and I. You can get a connection between R and I. How? This R, angle of refraction, must be equal to this 180 minus angle of refraction is 180 minus I plus 90, right? I plus 90. What is this one? R is equal to 180 minus 90 minus I. That means 90 minus I. Did you get that? R is 90 minus I because this is 90. It is given. So once you get this, you apply the Snell's law. N1 sin I is equal to N2 sin R. Sin I is sin I. Sin R is sin 90 minus I. Sin 90 minus I can be written as cos I. So you can solve it. This is one of the clues that are given for some problems. So this is another type of problem. So you keep on working out problems more and more because here understanding problem is one stage and getting experience with the problem is the second stage. If you are in the second stage, you can go to the exam and work out the problem confidently. If you know how to solve these problems, it is not enough because in the examination you are in a tension. You will have to use the logbook, sign table, everything, and this should be very fast. You will have so many things to write. Under that pressure, you will not be able to solve the problem. So only understanding is not the last stage. It is just one stage ahead, and you have to have an experience of solving all these problems. You should get the speed and you should get enough confidence, then only you can solve the problems in the final exam. All these things you should do yourself. Take new problems and solve it out. Get the experience. Once you get the confidence, you will definitely do it in the examination. So hope you will do many problems, solve many problems, get the answers. All the best. Do well. We will meet in the next class with a new theory. Thank you.